In this video, we'll explore the idea of average rate of change using the context of average speed. Suppose a child is playing with two toy cars. The blue car is spring-loaded, so it accelerates, as shown in this animation. The red car is battery-powered, so it travels at a constant speed when placed on the floor, as shown in this animation. Let's set the cars up to start at the same time. To make it a little easier to compare the speed of two cars, I'll add a vertical black line at the beginning of each second. So the blue car strip will look like this. And the red car strip will look like this. You might notice that the sixth mark on each line occurs at the same distance from the starting position. This tells us that the two cars had traveled the same distance in the first 5 seconds of their trip. Let's focus on the first 5 seconds. Let's set the cars up back at the start of the race again. Here's the animation showing both cars moving together. As you watch the animation, consider how you might determine the average speed of the blue car over the first 5 seconds after it started moving. To think about how to determine average speed of the blue car over the first 5 seconds since it started moving, let's construct a graph. We will orient the car to move vertically to more easily see how this graph is constructed. We'll graph the relationship between the blue car's distance from its starting position and the number of seconds elapsed since it started moving. Now let's just look at the red car. We'll now construct a graph of the relationship between the red car's distance from its starting position and the number of seconds elapsed since it started moving. Let's look at both cars together. We'll watch them race again. Notice that the graph intersects at the point 5, 70. This means that the red car's distance from its starting position is the same as the blue car's distance from its starting position 5 seconds after its car started moving. We can see from the graph that both the red and blue cars traveled 70 inches over the first 5 seconds since they started moving. But the red car traveled at a constant speed, whereas the blue car was accelerating. Specifically, the red car traveled at a constant speed of 70 over 5, or 14 inches per second. Since the blue car traveled the same distance as the red car over the first 5 seconds since they started moving, the blue car's average speed over this interval of time is equal to the constant speed of the red car, which is 14 inches per second. This is the meaning of average speed. In this scenario, the average speed of the blue car over the interval from t equals to 0 to 5 seconds was a constant speed required for the red car to travel the same distance in the same amount of time. And we can state this more generally. The average speed of an object over t1 to t2 is a constant speed required for another object to travel the same distance in the same amount of time. We can think of this graphically as well. Suppose this graph represents the distance of a blue object has traveled away from some initial position in relation to the amount of time elapsed since the object began traveling away from its initial position. And t1, t2 are 2 points in time. If we had a red object traveling same distance in the same amount of time at a constant speed, a graph of its distance traveled versus elapsed time will look like this. Then the amount of change in time represented by the length in this green line and the amount of change in distance represented by the length of this orange line. The average speed of blue object would equal to constant speed of the red object, which would be represented by the slope of this red line. We could compute its speed by dividing the change in distance by change in time. So this is the main idea of average rate of change.